Problem number 1 of axial deformation. A steel rod having a cross-sectional area of 300 square millimeters and a length of 150 meters is suspended vertically from one end. It supports a tensile load of 20 kilonewtons at the lower end if the unit mass of steel is 7850 kg per cubic meters and modulus of elasticity is equivalent to 200,000 megapascal. Find the total elongation of the rod. So for the given, for problem number 1, so meron daw tayong cross-sectional area equivalent to 300 square millimeters. Then the next, the total length of the material is 150 meters. Then next, so given is the tensile load equivalent to 20 kilonewtons, which is equivalent to 20,000 newtons din yan. So if the unit mass of steel or the density of steel is equivalent to 7,850 kilograms per cubic meter, and the modulus of elasticity of the steel is 200,000 megapascal, or equivalent din siya sa newton per mm squared. So determine the total elongation of the rod. So first, so we have the material supported at its one end. So, ayan. Total length is 150 meters. So, to determine for the deformation or elongation due to its own weight, so our formula for due to its own weight. So, formula for deformation is equivalent to PL divided by AE. Or if given naman is yung density, is equivalent to rho times G L squared divided by 2 times E. So, ayan. So, next is input lang all of the given. So, deformation is equivalent to rho, which is 7,850 kilograms per cubic meters times length. So length is 150 meters divided by, or squared pa pala, times gravity 9.81 meters per second squared divided by 2 times E. So E is equivalent to 200,000 newton per mm squared. So it means we need to convert the square millimeters to meter squared times 1,000 mm squared divided by 1 meter squared. So ayan. So the total deformation due to its own weight, so 7,850 times 150 squared times 9.81 divided by 2 times 200, 123 times 1,000 squared. So total deformation in meters, 4.3317 meters, or equivalent to 0. Times 10 to the negative 3. So if i-convert natin into millimeters, so equivalent siya sa 4.3317 mm. So ayan na yung deformation due to its own weight. Then next, so next naman is due to the load applied. So due to the applied load. So deformation is equivalent to PL divided by A times E. So P is equivalent to 20 kilonewtons times L. So L natin is 150 meters divided by AE. So cross-sectional area of the material 300 square millimeters times E, 200,000 newton per mm squared. So we need to convert kilonewtons to newton. So it means we must multiply it by 1,000. So ayan. So ito, cancel lang yan. Then cancel. Newton, Newton cancel. So, the total deformation is equivalent to 20 times 150 times 1000. Answer divided by 300 times 200. 1, 2, 3. So, ayan. So, total deformation is 0.05 meters or equivalent to 50 mm. So, to determine for the total deformation, so deformation total is equivalent to the deformation 1 plus deformation 2. So, 4.3317 mm plus 50 mm. So, 54.3317 mm. So, ayan. So, that's all for problem number 1.